All right, it's exactly 5 past 5. Like I mentioned earlier, we're going to always comment a section at 5 past 5. So the first thing I need to mention is this is the asthma program. All right, for those of you that did Maths 1 and failed, this is the alternative version. And very, very important, this is something I need to clarify at the beginning of our lecture is what's the difference in the code that you see? You notice I use asthma 1A1 and sometimes you see ASME 1A1. All right, so asthma A1, asthma 1A1 is for science students. So if you're doing science and you fail, whether you did math 1A01 or you did math 1A3E, the new code you're going to be using is asthma 1A1. And if you were doing engineering, so engineering 1 and you failed, then the code you're going to be using is ASME 1A1. All right, so please get your code correct. Because once we start doing assessment, which you can see, let me just get you can see there, we're going to start with assessment. So we have quiz 1, that happens in week 4. All right, so by the time we get to week 4, you should know what is your course code. All right, like I mentioned, there's only 2 course code, irrespective of what module you fail. I classify you guys as science or engineering. So if you were not doing engineering, then you need to use ASMA 1A1. But if you were doing engineering and you failed, then you need to do ASME 1A1. All right, because if you use the wrong code, I will be allocated different sets of questions for science and engineering. Although you both attending the same class, you're going to be writing basically different assessment. And if you are in the wrong group, then you'll be getting a lot of zeros. All right. So the study guide and this same semester program is available at the link that I sent. So the link that I sent, I will be updating this link every week. So before you come to class, you're going to see your lecture note. You're going to see the tutorial for the week and the recordings from the previous week. Also, I'll make the videos available for those that can attend. The videos will be there for them to go through. All right. And on Tuesday, you can see there was a welcome and overview, but I'm busy trying to do that quickly so that we can start with Appendix A and B. All right. I'm sure everyone has access to the link. I'm just going to check what you people are posting in the air. Okay, someone can hear anything. I think they just need to turn on their audio or something. And then for those that can access the course material, so I sent a link. When you click on the link, I think what's going to happen is it will ask you to enter a certain code, and that code gets sent to your email address. So when I was sharing the link, I put in your email addresses, and you guys should have access. So anyone that didn't receive the link from me will not be able to get access to the material, all right? Only if I send you an email with the link, and means that you'll be able to get a code that will enable you to view the materials. And it's very important to fix that as early as possible. If you keep having problems, send me an email. I will try to do it again. But make sure you have that sorted and you always have access to that repository, because that is where I'm going to be putting all the documents until such time when we move to Blackboard. All right. Is there any other question from your side? All right, someone recommended that you check your spam folder. That is correct. It's possible that the code gets sent in your spam folder. So check all your inbox, your spam folder, everywhere, right? And make sure that you can get the code. I see there's no other question. So all right, someone it got sent to the spam folder. So that's great. It means you guys can now see the code. So everyone should have access to these documents. Go over the document. Remember the important days. Because I'm not going to remind you that, oh, you're writing your test tomorrow. You need to know already, right? As we're going along, you should know already that your test is coming in 2 weeks and so on. And very important is your semester test. We are going to be writing 2 semester tests, and we're going to be doing some continuous assessment like your quizzes and your assignments. And very important, just to give you a little bit of a hint, your 2 semester tests will cover 70% towards your final semester mark. And the continuous assessment, so your quizzes, assignments, class tests, all of those will constitute 30% of your semester mark. So failure to submit assignments on time or complete your quizzes will affect you at the end of the semester. So make sure you always submit your assessment on time. When we get closer and closer to the first assessment, I will again explain all the rules how it works. And then for those of you that were complaining about the clash in the times, I think some of you say on the Thursday you have some other engineering course going on. All I can say is university policy will not allow to have lectures after 6 o'clock. So after 6, the only thing that can happen is maybe assessments. I can give you a test and I allow you to write up to past 6, but not me lecturing you after 6, so 7, 8 o'clock in the middle of the night. That doesn't work, all right? My best advice for the guys that have classes on a Thursday, if you have a clash, just make it a routine process that once you finish with the other class, you join as quick as possible, because I've allowed you guys to join anytime between 5 and 6. And also the recordings will be made available. So you can always go back, look at the video, look at the TAT, the memo of the TAT. I will give you the TAT and the memo of the TAT. If you still struggle, send me an email, make an appointment. I'm going to organize a consultation session, and then I'll explain what you're struggling with. There are also tutors. I will make the details available so that they can help you guys on one-by-one basis or as a class. All right. So for now, I hope everyone is happy. If that's the case, then we're just going to jump straight to Appendix A, because today, like I said, we need to complete Appendix A and D. And very important, when the session closes, you go back to the same link that they sent, and then you click on it again, you'll be back to the session. All right. So don't go away once this session ends. If you check your clock is not yet 6, it means that there is another session that's going to start. So you need to go to the same link, click it again, come back to the same class. All right. All right, let's look at let me just clear all of this drawing. All right, let's discuss Appendix A. So Appendix A is numbers, inequalities, and absolute values. All right. When we talk of numbers, let's discuss some of the number systems that we actually have. So everyone is familiar with real numbers. So real numbers is just all numbers that we have from minus infinity to infinity. And very important, it includes decimal values, right? When I talk of integers, again, it's all numbers from minus infinity to positive infinity, but now it doesn't include decimal, it's just whole numbers, all right? So the difference between integer and real number is real number includes everything that is decimals, and integers, you focus on whole numbers from minus infinity to infinity. And then there's something called rational numbers. Rational numbers, we're looking at fractions. So you have a number P over Q. Very important. P and Q has to be integers, and Q cannot be 0. It makes sense because you can't divide anything by 0. So the bottom here cannot be equal to 0. For example, look at this. Half, 1 over 2, that's a rational number. Minus 3 over 7. And take note, even 46 is a rational number, because all positive or negative whole numbers can be written as the same number divided by 1. So that makes it a rational number. And then look at stuff like this. 0.17. It's also rational because this is the same as 17 to 100. All right. Now, what is the difference between rational and irrational? All right. So irrational, look at the example. You have root of 3, root of 5, cube root of 2, pi, and so on. Now, the difference is that for rational numbers, you have repeating decimals. For example, if I say half is 0.5000, you see the zero that's repeated. So this thing here means it's repeated. And then if I say 2/3, give me 0.666, you see the 6 is repeated. So this is a pattern that you're going to see when you're dealing with rational numbers. Now for irrational numbers, the decimal values, they're not repeated. All right, let me just go down quickly. Start by clearing all of those. All right, just get the notation again. All right, you can see here for irrational numbers, look at pi, for example. You have 3.1415. You see there's no pattern here. It doesn't repeat. It's completely different compared to this rational value here. Look at this rational value. You have 0.3, but look at what happened next. 17, 17, 17. You see, it keeps going. It keeps repeating forever. So there you go. So the repeating term there is 17. That's rational. For irrational, you see nothing is repeating. So if you get decimals like this that are not repeating, it means it's irrational. Similar to root 2. Yeah, look at the decimals, it's not repeating. Now this is a little bit of a summary. So on the outer circle there, you see you have complex numbers. So this C stands for complex number. And then you go in one step, you hit real numbers. All right. So be careful, if a number is not real, it can be complex. So complex includes everything else. And if you move one step in, you have real numbers. And then after real numbers, you have rational numbers. And then you go to integers, and right in there, you're dealing with natural numbers or counting numbers. All right. I hope that was a good summary. Okay, let's move to intervals. Guys, if you have any questions to go along, just type it in, and then I'm going to check the comment area and give a quick explanation. Now for intervals, guys, pay special attention. Now, when we talk of intervals, you can have open interval, closed interval, all right? For example, if I say X is an element of AB, now I'm using round brackets here. It means that these are open intervals. This is another way of writing it. It just means X is less than B is greater than A. And then using set builder notation, I can still write it like this. So X such that X lies between A and B. All right. So this round bracket is equivalent to this sign. So you can see it's not equal to, it's just strictly less than or greater than something. That's why you see the round brackets. All right. And then for closed interval, on the other hand, now look at this. I use square braces. Square braces, very important. Square braces. And it's equivalent to something like this. Less than or equal to or greater than or equal to. All right. And set builder notation, we're going to do this. Now in a test, if I ask you to solve any inequality, how will I expect you to present your final answer? Guys, your final answer needs to be in set notation. Call this set notation. I want to see stuff like this. I don't want to see set builder notation. Most of the time, you guys tend to get this whole thing wrong. All right. Just give me set notation. Unless I specify set builder notation, which I will never say set builder notation. So just use set notation. Just give me something like this. I'll be very happy with that. Some of you tend to leave it like this. Again, you might run out of luck and have a mark. But if I say leave your answer in set notation, just give me this. All right. And then in terms of number line, what is this open interval means? Open interval means open dots. You see that? Open dots. All right. So if X lies between A and B, it means that you have open dots there. And the closed interval or the square braces, it means you have closed dots. You see the dots there are closed. We call them solid dots. All right. And look at this. It's closed on one end and there is open on the other end. What does that translate to? Closed dot and an open dot. Hope everyone is happy. And if I say X is greater than or equals to A, keep in mind, because there's an equal part there. If I say X is greater than A, obviously it's open dot. If I say X is greater than or equal to, all right, it means it's a closed dot and it goes on to infinity. All right. Please, can you mute yourself? I think someone's mic should be active. Just mute yourself. All right, guys, mute, mute, mute. Okay, let's continue. Now let's discuss inequalities and the rules around inequalities. All right, the first rule says if I add or subtract any number to both sides of an inequality, what actually happens? Guys, nothing. So your inequality sign is not affected when you add or subtract any number on both sides of an inequality. That's the first thing you need to remember. But now you're going to see that things are going to be a little different when we come to multiplication and division. So when you multiply or divide both sides of an inequality by a negative number, all right? Let's say, for example, I have A is less than B, and then I choose to multiply or divide by, let's say, -2. So I divide here by -2, and then I divide here by -2. All right, the fact that I'm dividing by a negative number is a must that I need to change the sign, all right, to a greater than. Guys, please, you must remember that. So when you multiply or divide by a negative number, you must reverse the direction of the inequality, always. All right, failure to do so, your answer is going to be completely wrong. All right, someone asked at the tutorials just for practice. Okay, guys, tutorials are for practice. If you remember when I was showing you the semester program, the test dates are there and those are what will count for marks. Anything else doesn't count for marks. So tutorials is just for you to practice. And you should get used to doing the tutorial problems before you look at the memo. Don't look at the problem, then look at the memo, and then you assume that you understand. That doesn't work. So do the problems and then look at the memo. All right. All right, another important rule is reciprocals. This is a very interesting one. So I will show you guys a quick example. 2 is less than 4. All right, everyone is happy with that? 2 is smaller than 4. Now, what happened when I take the reciprocal? Remember, reciprocal means you take 1 over the value. So there I say 1 over 2, it just becomes half. And I take the reciprocal this side. You see what happened? Half is not less than 1/4. So what needs to change? You need to change this sign to greater than. So the rule says that whenever you take reciprocal, you must also reverse the direction of the inequality. Very, very important. You must reverse the direction of the inequality, and provided that the numbers are positive. You see here the numbers I'm using, there's 2 and 4, they're positive. So if I take the reciprocal, then the direction has to change. All right. This example is very good because everyone is very obvious that 2 is less than 4, but is half actually less than 1/4? The answer is no, half is actually bigger than 1/4. So reciprocals for positive numbers swap around the inequality sign. All right, let's move to an example. I'll go step by step with these examples so that you guys know how you're going to answer my question in the test. This is a very basic example. So 1 plus x is less than 7x plus 5. All right. There are 2 ways of doing it, but you end up the same. So you can choose to take that side, and then you take all the constant value to one side. Another student might choose to instead take the x on the left to the right. It's fine. Anyhow you choose to do it, you end up with the same answer. I'm gonna show you now. So if I take 7x to the left, I end up with x minus 7x is minus 6x. And if I take just 1 here to the other side, I have 5 minus 1, which is 4. All right. But look at this. I need to divide both sides by -6. I'm trying to make x the subject. The unequal sign changes. You see the important. So what I wanted you to master in this first example is those rules of inequality. That says if you divide by a negative number, swap the unequal sign. Always remember that. Please, as usual, this is what I'll be marking. Set notation. Give me in set notation. So if x is greater than -2/3, greater than means open interval, all right? And obviously it has to be less than infinity. So if x is greater than -2/3, it has to be less than infinity, All right, so we use open intervals there. Yeah, say optional means that you don't necessarily have to show me in a normal line. So this is just for the sake of understanding. When I say x is greater than -3, it means I have an open dot and it goes all the way to positive infinity. All right, so this you don't have to include it, but if you include it, it's fine. All right, everyone is happy with that example. Let's move to the next one. Example 2. All right, for example 2, now I give you 4 is less than or equal to 3x minus 2 is less than or equal to 13. Again, we apply rule number 1 of inequality that says if I add or subtract my inequality by some number, the sign does not change. So in this case, I'm trying to make x the subject. So how do I get rid? I need to get rid of this minus 2. So the first thing I can do is to add 2 all through. So if you add 2 to 4, you see here we have 6. Okay, guys, the meeting would expire in 10 minutes. Like I said, just click on the link and rejoin the session. So if I add 2 on the left, I have 6 in the middle. If you add 2, notice it minus 2 plus 2 falls off, you're left with 3x. And this side, if you add 2, you have 15. The next step is just to divide all 2 by 3. And there you go, you have x lies between 2 and 5. And in set notation, if you notice it, this one is 2 is less than or equals to x. You can see that because it's an equal part, it's going to be square brace, close interval here. And this one, x is strictly less than 5, so it means it's open interval. All right. And like I said, again, this is just optional. If you want to represent it on a normal line, notice it. On 2, we have a closed dot, and on 5, we have an open dot. All right. Let's move to the next one. All right, no question. I'm assuming that this is easy stuff everybody understands, so we keep going. Now they want us to solve this inequality. Well, if you notice it, this example 3, it looks slightly different from example 2. I'm going to explain why. Because if you check on both sides here, you still have some expressions, right? So you have 4x, you have 3x, so you have unknowns on both sides. So you can't treat it like example 2, where we say we just maybe subtract 1 all through. If you do that, it doesn't really help you. For the previous example, if you look at it, look at what I'm highlighting here at the top. The trick here is that on both sides, you have just numbers. You have 4, and here you have 13. Those are numbers. So it's easy to make the middle term the subject by just adding or subtracting a constant value. But in this case, if you look at on the left, I have 4x. On the right, what do I have? I have 3x plus 2. These are different functions. All right. So now we're dealing with function. We need to split this inequality into 2. And what is the trick of splitting this inequality? Because this is one expression, so this is a single expression, we're going to use and. Remember, and stands for intersection. So I will start by splitting it in this direction. That says 4x is less than 2x plus 1. Then I'll say and or intersection. Then I'll split it again in this direction. That says 2x plus 1 is less than or equal to 3x plus 2. Solve these two pieces separately, and then your final answer, just use intersection. Remember, when you say and, you say the intersection of these two results. All right, and let's see how the intersection works. So x is less than half. It's just an open interval. You can see here, it's just an open interval. And x is greater than or equal to -1. It's a closed interval, all right? Because we say greater than or equal to, all right? So this statement here is intersection, all right? This is just another way of writing it, which is, like I said, I'll prefer you to give me in set notation. This is just another way of writing. And then on a number line, you can see what happens there. We have a closed dot at -1, and then we have an open dot where you see half. All right, so the trick there was just to split this into 2. All right. Now I'm sure someone is going to ask me, well, what happened if I split the first question? So this question, question 2, you choose to split it into 2 statements using intersection. Well, my answer is you will still get the final answer to be correct. All right. but you must have done a little bit more work. It's easier if you just add 2 on both sides and you divide all 2 by 3. All right, it's just much easier. And consequently, you end with the same answer, all right, if you choose to split it into 2 different statements. All right, I see there's a question. All right, the recordings will be made available only after the class. So the recording for today, I will make it available after this class. All right, so I'll have to compress the video, upload it in that folder for videos, and then when you guys access the directory, you can see the recordings there. All right, I still have to compress it first so that it doesn't eat all your data. All right, let's keep going. All right, example 4. Now things are getting a little bit more practical. When I use the word practical, it means these are the kind of stuff that I can actually ask you, all right? So I give you some quadratic expression. Let's say x squared minus 5 plus 6 is less than or equals to 0. Right? Your first step obviously is to try and factorize this. So look for 2 factors, x minus 3, x minus 2, that works perfectly. And try to solve for critical values. So critical values is just equating each of these to be equal to 0. So if x minus 3 equals to 0, you see x there will be 3. If x minus 2 equals to 0, x is equals to 2. So your 2 critical values is 2 and 3. Now you have 2 ways of doing it. I won't force you to use a specific method. Some of you, I think from high school, you like using table. But I will tell you today that the easiest way that will save you time in a test or an assignment or any assessment you're doing is method 2, number line. How does it work? You put in your critical values, obviously in ascending order. You see the 2 critical values because I differentiate critical values from non-critical values using these lines here, the broken lines. Now I need to test 3 areas. So I need to test this area. What happens there? What sign do I get? I need to test this area in the middle, and I need to test this area. So I have 3 areas I need to test. Now, when I talk of 3 areas to test, it means that you have to choose some value for x within this interval. So for minus infinity all the way to 2, and you're going to plug it here and see what actually happens. So you plug it there and then see if you get a positive or a negative sign. For example, let's choose the easiest one. Obviously, you can see 0. We can choose 0 because 0 is less than 2. If I put 0 here, what do you observe? You get minus 3 times minus 2. You see is actually 6. It's positive. There we go. That's why you see I put positive. And then I choose some value in this interval. So between 2 and 3, I can choose maybe 2.5, 2.5. If I come back to this expression here, I put 2.5. Notice it, I have 2 minus 3 is negative, right? 2.5 minus 2 is positive. Negative times positive, you see it's negative. That's why I'm just interested in the sign. They have negative. And similarly, if you choose a value in this interval that is from 3 all the way to infinity, you can choose 4. And any number like 4 or 5, if you come and plug it in here, notice it, you just have 4 minus 3 is positive, 4 minus 2 is positive, positive times positive is positive. So very important, you getting these signs correct, you're going to get marks for those. And how do we conclude now? In conclusion, we're going to we go back to the inequality. The inequality say it has to be strictly less than or equal to 0. It means we're focusing on what? The negative regions, all right? Less than simply means we focus on the negative region. If it was greater than, we could have been looking at the positive region. So in this case, this is our region of interest. So it lies between 2 and 3. There you go, between 2 and 3. Now you need to ask yourself, is it closed interval? Is it open interval? The trick here is to ask yourself, if I put 2 in this expression here, is the inequality satisfied? The answer is yes, because you end up with 0 is less than or equal to 0, which is true. So it means that you can actually plug in 2 itself, all right? And also test for 3. If you put in 3 in there, in this expression you have 3 minus 3 is 0. So you end up with something like 0 is less than or equal to 0. And again, it's true, all right? Because 0 can actually be less than or equal to 0. That is why I also have a closed interval there. So guys, please always test if you're dealing with closed interval or you're dealing with open interval. All right. I see someone ask a question. Do we have to show the method in a test? Yes, you need to draw a number line. So I can ask you to solve this and then you just go all the way and give me this final answer. No, if you do that, I'm going to ask how did you get there? So show me how you factorize. From factorizing, you don't necessarily need to show me critical value. You can show me on a number line. So first I'm looking for is factorizing. I'm looking at your number line where I'm going to read off your critical values. I see the signs and then I see your conclusion. And that's how you're going to get all the full marks.